Hi, my name is Sam Drake. I'm an architect in Oracle TimesTen In-Memory Database development. And I'm going to talk to you today about the TimesTen Kubernetes Operator. I guess before we talk about the Kubernetes Operator, we need to talk about Kubernetes. If you haven't heard of Kubernetes, it is a very popular platform for managing containerized applications across a cluster of nodes. You may have heard of technologies like Docker, which are very popular for building containerized apps. Kubernetes has turned into the major platform that's used for actually deploying them in production environments around the world. A nice thing about Kubernetes is that it is portable, meaning that basically every major public cloud, including the Oracle public cloud, provides support for Kubernetes clusters. In Oracle Cloud, it's called OKE, the Oracle Kubernetes Environment, but all the other cloud providers have Kubernetes environments as well. It's also increasingly being used for on-premises deployments as well in customer-owned data centers. Basically what Kubernetes does is it allows you to create, monitor, and manage collections of containers across a pool of virtual or physical machines called nodes. So basically you can take a whole bunch of computers, combine them together into a Kubernetes cluster, and then deploy workloads across them without worrying very much about the boundaries between those individual machines. Kubernetes will provide transparent networking between all of those containers so that they can communicate regardless of where they're running. And it'll automatically restart applications that fail and manage them in a pretty nice manner. Now, like all containerized environments, Kubernetes was initially used to manage stateless applications, web servers and things like that. That if an application dies, you can just start another one. There's no big deal. But these days, Kubernetes is being used more and more by companies to deploy all of their applications and all of their software, including databases. Databases are a lot more complicated than web servers, and so there's a fair amount of work to do in order to make databases like TimesTen run well in the Kubernetes environment. The first thing I should say is that TimesTen is itself certified to run in containers managed by Kubernetes. Regardless of whether you use the TimesTen Kubernetes Operator, which we'll talk about in a minute, or some other environment to deploy them into Kubernetes, TimesTen itself is certified to run inside of containers managed by Kubernetes. We've done that certification with the Kubernetes 1.13 running in the Oracle Kubernetes environment, OKE, running under both SUSE and Oracle Linux variants inside of the containers. But the main topic of today's talk is the TimesTen Kubernetes Operator. And first I have to explain what a Kubernetes operator is. As I said earlier, Kubernetes will manage the life cycle of containers. Say you had a web server running in a container, and maybe you started 20 of them because you've got a big website. You need 20 web servers to handle all your traffic. Well, if one of those containers was to die, Kubernetes would notice that and go, oh, I only have 19 containers running and there are supposed to be 20, so I'll start another one. And it would automatically start another one for you. Now that's really nice, right? That lets you make sure you tell Kubernetes what it is that you want, and Kubernetes will make it happen. Even if you have hardware failures or other failures, it can react to them. But that assumes a fairly simple application inside of a container, right? If the application dies, it'll start another one. But that's really all it knows how to do, is detect those failures and start things up. It doesn't really know what's going on inside of those containers. And if you have a really simple application like a web server or something, then there isn't a lot going on in there. It's either up or it's down. But databases, for example, are much more complicated, right? You have to create a database, and you might have to configure replication, and you might have to do a whole bunch of other sort of housekeeping functions in order to keep your databases running successfully. And Kubernetes doesn't know anything about those, right? Certainly not for in a generic way, and certainly not for databases like TimesTen. So in order to allow basically us to teach Kubernetes how to manage more complicated applications, Kubernetes supports something called an operator. And an operator is basically an application that performs the job of a human computer operator, right? You can think of an operator as a computer program that will create and monitor and manage other application programs for you, according to some certain set of rules that were defined in the operator itself. So an operator is an application running in a container that knows how to create, monitor, manage, babysit other applications. So Kubernetes has this generic facility to support operators built in, and it's a really nicely done. And so as part of the Oracle TimesTen In-Memory Database product, we have, in their newest release, we have added a Kubernetes operator that supports TimesTen Classic deployments to the core TimesTen product. The TimesTen Kubernetes operator can create containers running inside of Kubernetes into which it will automatically create TimesTen databases and set those databases up using a set of metadata and attributes that you define. For high availability, the Kubernetes operator that TimesTen provides also will automatically configure TimesTen's very fast active standby replication between them. So when you ask us to create a TimesTen database using the Kubernetes operator, we will automatically create two, an active and a standby, and we will configure replication between them automatically. Once that pair of databases is configured, the operator's job isn't done. The operator will continue to monitor the health of those databases and the containers and pods in which they're running, and can take action to fix those problems that it finds. So for example, imagine that if you have an active standby pair of databases, right, where one database is the active, you have application workloads running against that active database. The changes to the database that the applications make are being replicated over to the standby, which is running on a different node, so that if the active fails, then you can fail over the workload to the standby, minimizing the amount of downtime that your application sees. Well, the TimesTen Kubernetes operator can monitor those databases, detect that problem, and automate that failover. So, without human intervention, will automatically fail over to the standby and have your applications continue to run. After that, of course, as the TimesTen Kubernetes operator can then bring up a new standby database running in a new container in a new pod to replace the failed one, so that returning your environment to a highly available configuration. And the Kubernetes operator can do this for many pairs of TimesTen databases simultaneously. You can install the TimesTen Kubernetes operator into your Kubernetes cluster one time and have it manage as many pairs of TimesTen databases as your application, as your environment requires. And the configuration of these TimesTen databases is done using simple configuration files, typically using the YAML format. You see a very simple example of that on the right side of this slide. As I said, the TimesTen Kubernetes operator is a core part of the TimesTen product. It has been developed using Kubernetes 1.14 in the Oracle Cloud using the Oracle Kubernetes environment. But I have to say that the TimesTen Kubernetes operator does not use any specific features of OKE or the Oracle Cloud. It is written to the Kubernetes APIs and interfaces and should function in any Kubernetes environment. The Kubernetes operator is part of the standard TimesTen product, as I said. If you have a license to run TimesTen, then you have a license to use the Kubernetes operator as well. And because the TimesTen Kubernetes operator is part of the core TimesTen product, your existing support contract for TimesTen covers the operator as well. So if you have any issues with it, you have the same support for the operator as you do for the rest of the TimesTen in-memory database. So let's walk through a real simple example of creating a pair of TimesTen Classic databases. This is the simplest hello world example we could possibly do, right? First of all, we're going to start with a configuration file. On the right side of the screen, you see a very simple file called payroll.yaml. We're going to use that to create an object in Kubernetes of type TimesTen Classic called payroll. We're going to allocate 50 gigabytes of storage to hold the database inside of it. And there's a little bit more information there, but that's the basics that you have to specify. Naturally, this can get much more complicated, but for a simple example, you just say, I want to have a database and I call it payroll. And after you create that configuration file, you can issue a command called kubectl create. The kubectl command is the command that's used as part of the Kubernetes product that is used to control Kubernetes. And we can point Kubernetes at that file and say, hey, I want to create that TimesTen Classic object called payroll from the specification in that file, in the YAML file. And Kubernetes will go off and do it. By creating that one configuration file and issuing that one command, you cause Kubernetes to automatically go off, communicate with the TimesTen operator to let the operator know that that object has been created. And the operator will then instruct Kubernetes what to do in order to bring up the containers and et cetera that are necessary in order to run those two copies of the TimesTen database. So for example, when you create a TimesTen Classic object to create a pair of TimesTen databases, the TimesTen operator will automatically create some additional objects inside of Kubernetes. It will create what's called a stateful set, which will cause Kubernetes to create two pods, each containing containers running TimesTen. So 2 copies of TimesTen will automatically be started. Kubernetes will also be told to create several persistent volumes to hold these databases. Remember, TimesTen is called an in-memory database, but it actually stores data on disk persistently, or in flash these days persistently. And so we will create, we need storage in order to hold those databases. Once Kubernetes creates those stateful sets and pods and persistent volumes, the TimesTen Kubernetes operator will start TimesTen in each of those pods automatically. We'll create a new database in one of them. We'll copy that database to the other one, and we'll then configure active standby replication between them so that the databases are kept in sync from then on. So just with one simple little configuration file and a couple of commands, you can easily roll out a whole new pair of TimesTen databases without any other work. The operator takes care of everything for you at that point. Once you've created that pair of TimesTen databases, of course, applications can use them. The TimesTen operator running in Kubernetes will also instruct Kubernetes to create what's called a headless service, which will expose the databases in those TimesTen pods to other applications in other pods via client server. And those applications running in other pods can then access the databases that you created using TimesTen standard client server APIs for Java, Python, R, C, C++, all the APIs that you can use outside of Kubernetes, of course, you can use inside as well. And because this is a replicated environment, TimesTen will automatically route those application connections to the active database. So you can have, in this example, we see a whole bunch of application pods, and they're automatically, when they try to connect to your payroll TimesTen database, they automatically get routed to the active one.